on Canvas of the recordings of the labs and the lectures. So you can consult that too if you have any questions as well. So now I can move up. Okay. So I will be doing a little bit complicated looking circuit, but it should be easier to solve. So this is example from your book. And we have to determine resistance at terminals A, B in the network. So when we are solving the circuit, it's very important to see what we have to find. We cannot just try to find every current, every voltage, and every resistance. We have to see what we are trying to find, and then we will go from there. Okay, so okay. So we are supposed to find RAB because this is A and this is B terminals. So you can see that in this circuit, there is no voltage source, right? So it's assuming that we want to find the equivalent resistance. There could be a circuit behind it, but we can just find the equivalent resistance by looking at by solving the circuit without even the voltage source. So it's something like that. If you have connected to your circuit and the source, so what you are seeing here at the input side behind the complicated circuit, it's the equivalent resistance. So this RAB is also called equivalent resistance of circuit. So if you measure your resistance here with your ohm meter, it should give you this RAB. Because ohm meter doesn't know what's behind that. Similarly, if you connect this circuit, if you connect these terminals A, B to some other circuit, the other circuit also see the equivalent resistance, okay? So that's why it's important to know how we solve it. So what I will do, I cannot just solve the whole circuit at once, okay? So what I will do, I will start from one side to start solving it. And how you pick the one side, the side that is more clear in concepts to you, and you think that that could be the starting point, should be the side, okay? So in this circuit, from where should I start? What do you think? I mean, it looks complicated, I know, but I will start from this side. okay? So I will simplify, I said, right? So if I see first combine these two resistances, what do you think these resistances are? They are in parallel, they are in series, what do you think?
Series.
Series.
Who said parallel? It's okay. I mean, why you think that it's parallel? So for the resistance to be parallel, this should be a node where the current should be divided, right? So in this node, the current is not divided, but the same current is flowing here, okay? So this is in series. Sometimes I know it looks confusing when you see the circuit that whether they are series and parallel. I recommend just focus on small part which you are trying to solve. Don't look at the large part. So these are in series, and I can replace my circuit like this. Okay, another thing I want to ask, that this 6 kilo ohm, I know it looks a little bit complicated, right? But when I combine these 3 kilo ohms resistance, 1 kilo ohm plus 2 kilo ohm, what do you think I should draw 6 kilo ohm like it should be? How I can simplify it? Can I do that? Okay. So okay. So what do you think? 3 and 6 kilo ohm can be drawn like that?
Yes.
Why I'm drawing it like that? Because if you see 6 kilo ohms, it was connected before between the terminals, this and this, right? Yeah, go ahead. Hello. Can you hear me?
Yeah, we can.
Okay. So what I was saying is that if you see these two terminals, right? These two terminals are directly connected to 3 kilo ohms terminals. So it's something like that. Right? Right?
Yeah.
And
Yeah.
Yes.
that can be done as, there is no harm in doing that because we are not adding any component here, but we are just extending a wire so that it looks a little bit easier to understand, right? You can extend a wire without adding any component. So that's what exactly we are doing here. So this is in parallel. So what we have done before, 3 kilo ohms is equal to 1 kilo ohm plus 2 kilo ohms, right? This was our 3 kilo ohms. Okay. Now these two are in parallel. So let's see. So we know when the resistors are in parallel, let's say R1 and R2, we can use this formula. So these two are in parallel. I can do this. 2 kilo ohms, right? So this is 2 kilo ohms, and I can draw this like that. If you see, I'm not worrying about other resistors right now. I'm just thinking about one resistor at a time, which I have to tackle. Right? So now what do you think? What should be my next step?
Combine the 10 kilo ohm and the 2 kilo ohm resistors.
Yes. So now I will do this. So how I can combine them? What should be the equivalent resistance here?
You just add them because they're in series, so it would be 12 kilo ohms.
Yes. So I will just add them. So this will be 12 kilo ohms is equals to 10 plus 2 kilo ohms, right? So this is here, and I can just add this like that. So we are good. Okay, so now you can see 12 kilo ohm and 6 kilo ohms are in parallel. So we are dealing one at a time. So these are again, what you should say, two resistors that are in parallel. So we will again use this formula. So this is 4 kilo ohms. Yes, so okay. So now these two resistors are in series. So this will be 4 plus 2. Right? So I will do that. Okay. So you can see that I am just dealing one resistor at a time, right? I'm just not thinking about other resistor, and it is automatically simplifying the circuit. So this 6 kilo ohm will be okay. So what do you think? This 4 kilo ohms is in series with 9 and 3 kilo ohms? What do you think right now?
I don't think it is, no.
Yes. So any other person who thinks that they are in series or in parallel? What do you think? Do you all think that they are in parallel?
It's in series because there's no node that separates them.
Okay. Any other person who think that they are in series?
I think they're in series.
What is in series? 4 kilo ohms is in series with the 12 kilo ohms? Or 9 and 3 kilo ohms?
Oh, between them, it's parallel. I thought you were the highlighted part you were talking about.
No. I'm
Pardon?
talking about 4 kilo ohms. Is it in series or in parallel? Ismail, do you think 4 kilo ohms is in series?
No, I thought you were talking about the highlighted part. Sorry.
No. I'm talking about 4 kilo ohms. So is it in series with other 9 kilo ohms and 3 kilo ohms?
No, it's parallel.
Yes, it's in parallel because it looks like that it's in series, but if you see, there is a 2 kilo ohms resistance here. What happens if there is no 2 kilo ohm resistance? Will it be in series or parallel?
It would be series because then the current wouldn't get split.
Yes, it would be in series even if you have these two terminals out, right? If this 2 kilo ohms was not there, then you can draw this circuit as so this circuit shows that you are trying to measure the voltage across 4 kilo ohms, but all three resistors will be in series, right? But right now, you can see that this is 2 kilo ohms that you can see is in the circuit, right? And it is dividing the current. That's why you cannot take them in series. So these, if this is the situation, then 3 resistors are in series, okay? But right now, because of 2 kilo ohms, the current is dividing there and it's not in series, okay? So, okay, so let's move from there. 9 kilo ohms plus 3 kilo ohms is equals to 12 kilo ohms, that's right. Okay, so now they are in parallel. Right? And if I draw the final circuit, it would be right. So as we know that this is AB, so this is VRAB, which is equals to 5 kilohertz. So is it clear? So how we went like through all the process, there are two things we took care of. We started one end, right? We did not tackle multiple ends at the same time. The other thing we did is we consider minimum resistances at the same time. So we did not look at the whole circuit at once. We just deal with them one by one. Then that's how we make the circuit easier for us, right? So, okay. So are we good about it? Okay. Okay, so I will solve. So I feel that as many problems I will like, if I solve maximum number of problems, so through the solving process, we talk about the things. So it's easy to understand. So that's why I am trying to solve as many problems as I can. So if you see, there is one more thing I want to talk about. So I think we have done previously one question in which we were trying to solve multiple sources. So multiple sources can be in series, can be in parallel, but we need to take care what type of source is this. So I just want to summarize this thing as, so if you have a source, so it matters if they are in series or in parallel. So let's say I have a current source and I have a voltage source. So we have not seen current source in series yet without having any component here. So, but we have seen current sources in parallel. Similarly, if I talk about voltage source, they can be in series. But can they be in parallel? So to understand them, you just think about KCL and KVL, right? So KCL thinks that at any node, the current entering should be equal to current leaving. And KVL thinks that in the single loop, all the voltage drops should be equal to 0. So if you think about this thing, so if we take currents in series, then these currents both will not satisfy either KVL or KCL. So this does not make sense until and unless you have some resistance in between, right? But if you see here, you are satisfying KCL, right? Because this current is entering in this nodes the same. So currents are entering here, and maybe if they are leaving, there will be some of that, right? And there could be any circuit beyond that. So this is possible, makes sense, because it satisfies our rule, KCL. Now, if you think here you can see that this actually possible because you can add voltages and they can be given to others. So this is satisfying KVL, right? So this is okay. But if you think here, so in this thing, you are having two voltages at the, so this can be 12 volts, this can be 9 volts. If they are in parallel and there is a single node, there will be no 1 voltage drop. So it's not satisfying any KCL or KVL. That's why this does not make sense, right? So we should be, when we are talking about multiple sources, we should be aware of the scenario that the sources we combine should satisfy one of these two formulas, right? One of these two rules, like KCL and KVL. Okay. Okay. So let's solve another circuit. So this is a single source series parallel interconnection. Okay. So it's the same as we have done before, but here in this case, we will calculate currents and the voltages. Okay. So let me start. Okay. Okay. So the currents that are flowing are, this is I1, this is I2, this is I3, this is I4, this is I5. Okay. So what we have to do here in this circuit, so they said, try to find all currents and voltages, okay? So, and they have defined that this voltage drop is VA, this voltage drop is VB, and this voltage drop is VC. Okay. And we are not given any current beyond resistance or voltage, okay? So we have to find them. So first, I think as we don't know any currents or voltages, so maybe if we try to simplify the circuit and find out the total current, that is I1, right? So let's see. How we can simplify the circuit? By finding the equivalent resistance, right? So if I do this, then my goal is to find I1 after finding this RT, the resistance that I can see here, okay? So let's try to see that. So I will do this first. 12 kilo ohms, 4 kilo ohms. This is not as complicated as the previous one. Or is it 9 kilo ohms? Okay. So should be doing this. So for when you solve it, you try to name the resistance so that it will be easy to keep track of it, okay? I'm just not doing it.
Excuse me, could you go up to the previous drawing? Oh, okay, thank you. I had it written down wrong, sorry.
It's fine. What I'm doing is, okay. So 3 kilo ohms I got here. So if you notice here, another thing I want to mention, that the voltage that you will get here, the voltage that you're getting here, that is VB, is the same voltage that will be in this node, right? And it will be the same voltage that will be at this area, right? So this VC is actually the division of VB. Do you understand what I'm saying? So VB actually is the same voltage that you will be having across 9 kilo ohms plus 3 kilo ohms, right? And VC is kind of the voltage division of VB. Right?
Yes.
Okay, so this was VA. Volts, VA 6 kilo ohms. Similarly, this VA is the same voltage that you will have across these two resistors. So this is actually VA. That's what we can say as well. So this will be okay. So finally, you are getting I1. That will be right? So what we are doing here is so I1 is Vs divided by 12 kilo ohms. That is 12 volts divided by 12 kilo ohms equals to 1 milliamps. Right, so we are good with the source resistance. Okay, so we will try to find all the other voltages and the resistances, but let's see first the circuit again. So now you can see that we have I1 that is 1 milliamps, right? Okay, so now we have to expand it again, right, to see all the voltages and the currents. So once you have I1, what is the immediate thing that you can find out?
The voltage on the 9 kilo ohm resistor.
Yes, voltage across 9 kilo ohms resistance, right? And another thing that you can find out will be what? So another thing you can observe is that your I1, your I1 is actually dividing between I2 and I3, right? So we don't know about I4 and I5 because I3 is dividing further. But right now, your I1 is dividing between I2 and I3, right? The other thing that can be found out after finding this voltage is this voltage, right? So we will try to do that. So in the step 3, what we are saying is expand the network and apply Ohm's law, KVL, KCL. What do you think can be applied? Voltage division, current division. These are the all possible scenarios we can encounter with to determine current and voltages. So in this case, as we have to do all the current and voltages, then that's why we are doing this, okay? Sometimes you don't have to find out all the current and voltages. Okay, so what we are trying to say that we can find the voltage across 9 kilo ohms resistance. That is 1 into 10 to the power minus 3 multiplied by 9 kilo ohms. So it is 9 volts, right? So this 9 volts, VA is actually VS minus 9 volts. Why? Because this is your source. This is 9 kilo ohms, and this is VA. Right? And this is rest of the circuit. This is 6 kilo ohms. Okay, so VA can be found out by subtracting this, right? So this is VA is equals to 12 minus 9 volts is equals to 12 volts minus 9 volts is equals to 3 volts. So now you know VA, right? So this is I1, this is I2, and this is I3. Okay, so you can find out, what is the next thing that you can find out? That's, you know the VA. So you have to find out I2 and I3, right? So how can you find out I2? Okay, why I wrote, okay, just a minute. I just want to make it clear that why I wrote this. So as you know, in the loop, when you go, you can write this as KVL to that. Right? Do you think it's fine?
I think so.
Okay, just a minute. So when I apply KVL in this loop, I already told that you think about the current from where it's entering, right? So it's entering from the negative terminal here. That's why I wrote minus VS. This should be this. So it's my V 9 kilo ohms. Then this VA passing from 6 kilo ohms. So this, I just wrote this VA. So when I rearrange this, I can find out like this, right? It's important to know. I mean, it's if it's not clear, just tell me. If it's clear, tell me.
Yeah, I understand it.
It's clear.
Okay, so this is VA, that is 3 volts. Now I have to find I2, right? So how I can find out I2?
Can you use the voltage and resistance of the 6 kilo ohm resistor to find I2?
Yes, yes. So for that, I have to apply Ohm's law, right? And Ohm's law says V is equal to IR. Okay, so which means in this case, VA is equals to I2 into 6 kilo ohms, right? And VA we know, so it's 3 volts divided by 6 kilo ohms. So it's 0.5 milliamps. We are clear about that too, right? So now we are done with this thing. We found all the voltages and the currents in this box, right? We can move further. So I2 is 0.5 milliamps. Now, one thing you are taking from there. So you know that at this node, I1 is entering and I2 and I3 is leaving. So I1 is equal to I2 plus I3 if we apply KCL, right? So I just do here, apply KCL means I1 is equal to I2 plus I3, right? So So I will stop here. I will try to solve these things first, and then I will move further, okay? So I know all these things, except I don't know I3, which I will find out, and I have to know I4 and I5. Okay. So I3, I need to know I3, right? So I1 is 1 milliamps, I2 is 0.5 milliamps. So I need to find I3. So I3 will be 0.5 milliamps. This is good. Now I can find out, applying Ohm's law, I can find out this voltage drop, right? And this voltage drop across 3 kilo ohms will be right? So if I move further, I will do the same, right? I will apply, I will try to find VB, and I will try to find I4 and I5, right? So VB, how can I find out? I know I3. I don't know I4 and I5. What do you think? How should I do what VB?
Using KVL.
Yes. So I know all the voltages except VB?
Yeah, in the loop that we'll be using.
Yes. So in this loop, I know all the voltages, right? So I will apply KVL. And write it like this. So the equation, if I apply KVL, will be minus VA plus V3 kilo ohms plus VB is equals to 0, right? So I will write same equation here. Minus VA plus V3 kilo ohms plus VB is equals to 0. So my VA is 3 volts, I think. Yes, so VA is 3 volts minus 3 volts plus 3 kilo ohms is 1.5 volts plus VB. Okay, I need to double check that what my VB will be. VB is 1.5 volts, right? So we are going good. So we got VB. Now if we got VB, we can find out I4 and I5, right? So how I can find out I4? So there are more than this way of solving the circuit, okay? So, I mean, you can do any way of solving it. I'm just trying to find the easiest way to make it like understandable for everyone. So we did find I1, we did find I2, we did find I3, we found 9 kilo ohms, like the voltage across 9 kilo ohms, we found VA, We found voltage across 3 kilo ohms. We found VB. Okay, the things which we have not found yet are I4, I5, and VC. So do you think it's now easy to find these things, right?
Yeah.
So now we got VB. Now we will find I4, applying Ohm's law. So VB is I4 into, what is this resistance? 4 kilo ohms. 4 kilo ohms, right? So it will be I4 into 4 kilo ohms. So I4 will be 1.5 volts divided by 4 kilo ohms, and it's 3 by 8 milliamps. Okay. So now I will find applying KCL. So what should be my equation in KCL? At
Be
this node.
I3 equals I5 plus I4.
Yes, right. So that should be my equation. And we know I3 is 0.5 milliamps. I4 is 3 by 8 milliamps. So we are trying to find I5. So this is equal to okay. Okay, G. So no. This is not I1. This is I5. Sorry about that. So we're good with I5. We found I4, I5. The only thing that we need to find now is VC. So there are two ways to find VC. Either we can apply voltage divider rule to find VC, or we can just multiply our current with VC, like 3 kilo ohms, because this is the same current that's flowing here, right? So I5 is 1 by 8 milliamps. So let's see. So our VC is, let's see if apply Ohm's law. So my VC is I5 into 3 kilo ohms, which is 1 by 8 into 10 to the power minus 3 into 3 into 10 to the power 3. Just need to confirm the answer. Yes, it's fine. So VC is 3 by 8 volts, right? Okay. But if I try to find using voltage divider rule, I will do that. Do you remember the voltage divider rule? So voltage divider rule is, so this is an alternate way of doing it, okay? So voltage divider rule is, if you have R1 and R2, let's say this is R5 or R6. So this will be, let's say this is R5, this is R6. So this should be R6 divided by R5 plus R6 into, what voltage should I have? So if I'm trying to find VC. What voltage? So it's an input voltage you have, right? When you are trying to find output voltage, You multiply the resistor across which you're trying to find the output voltage, multiply by input voltage. So for this circuit, what is the input voltage? So for this one, this node, it can see as an input voltage, right? So this thing is its input voltage. So we can just, like, this output circuit sees like that. It doesn't know what is behind it. So this VB will be its input voltage. So R6, 3 kilo ohms divided by 12 kilo ohms into VB. VB was 1.5 volts. So 3 divided by 4 into 3 divided by 2. So VC is 3 by 8 volts, which is the same as this one. Got it?
Yeah.
Okay. So it's important to decide when you solve the circuit, it's important to decide when you apply what rule, right? So I recommend, it's your choice, but I recommend try to find the easiest way. You can always verify it using other rules, but it's better to find the easiest way to, and it's good to verify things. Like if you can find out using the Ohm's law and you can find out using voltage divider, you should be able to do it. So we are good about this. Okay, so I will just try to do another example. I think that is important to do. Not sure how much we can do it, but let's try to solve it. Okay, so till now we have dealt with, like we tried to find the currents and voltages of circuit with the single source, right? So right now we will try to find the circuit which will have multiple sources. So let's do that. Do you like this or are you bored about it? What do you think?
I
Is it
like doing examples. It helps.
Yeah, these are good examples.
Yeah, it really helps.
It's helping you.
You like it? I mean, trying to see, I feel that trying to see the whole process helps a lot, right?
Yeah.
Okay. Let's try to do another example. So this is multiple source, multiple loop. So in other classes, how you do quizzes? What is the way of quizzes they are doing?
I think they're doing take home.
Take home. So in the take home, you have a deadline to submit them.
Yeah, like they put it on Canvas, a multiple choice quiz and stuff like that. So my professors.
Okay. So most of them are doing take home?
Yeah, because Canvas has a thing where like it can like time you. So like the quiz will close after a certain amount of time, like once you start it.
But you could start it whenever, like before a certain date.
Yeah, that's fine. But is it the problem of people can do it together or something?
They have like the features or whatever they've been like talking about. Like you can check, like you can like put all these like security features so that students can't browse certain things on Canvas or open other tabs during the quiz.
Okay.
Like a lockdown browser or something like that.
Okay, I have to check then. But whatever the case will be, I'll let you know. But just prepare for the quiz for the next week. Okay. Okay. So let's see this network. Okay. We are given this V naught is equals to 4 volts. Okay, so this is our I1, this is our I2, this is our I3, this is 3 amps, I8, I7, okay, okay, yeah, okay, okay, I2, I7, I6, and I5, I4. This is VS. This is voltage. Yes. Okay. So this is 8 volts here. This is 2 ohms here. 3 ohms. 1 ohm. 6 ohm. And 2 ohms here. Okay. So it's important to know what we want to find, right? So they said find the value of Vs and voltage across current source VAD. So it means that we have to define nodes as well. So this is A, this is B, this is A, this is B, this is C, and this is D, and this common node is E. So we are given VDE because this thing is VDE that we are given, but we have to find VS and the voltage across current source AD. So we have to find this AD too. Okay, so we have to find VAD and VS. Okay, so if we just have to find VAD, we just don't have to solve a lot. But as we have to find VS too, it means that we have to find I1 as well, right? So we have to do all the scenarios. So it's okay. So first start with the known scenario, right? We know something, that is V naught. So from knowing V naught, we can find out one more thing, which is just don't look at other parts of the circuit. Just look at that one. From V naught, what we can find out. Yes, Mayor?
Oh, I was gonna say I8, right?
Yes. So from V naught, we can find I8. Two amps, right? Okay. Now, if you think your node D has 2 currents entering and 1 current leaving, right? So we can write it as, so we have applied KCL, Ohm's law here. So at node D, we will apply KCL. So at node D, you can see that we have I7 and I3. This is the same current that is flowing, I3, right? Because there is no more component that is attached here. So the same current I3 is flowing here. So we can just say I7 plus I3 in this node D is equal to I8. Okay, so I3 is 3 amps that's flowing in it. And we can find out I7 from there. So you can say that your current is dividing here and it's different here, it's fine. But for I3 that is flowing here, it's 3 amps it's taking that is flowing through it. So that's why we are taking 3 amps, that is I3. So I7 is I8 minus I3. So this is 2 minus 3 amps. This is minus 1 amps. Okay, we are good till here. We find out I7. Okay. Okay, one more thing you need to know now. So if you see the circuit, you have CD, VCD. This you have, right? This is 8 volts in this branch. And you have VDE, this one, VDE also, that is V naught. The other unknown in this loop is VCE. So we can apply KVL here to simplify it or to find out. So okay, so just looking at this loop in terms of voltages, VCE, VCD, or VDE, can you write the equation? It's okay if you mess up, it's okay. But I'm just trying to find out that if I just think about this loop, what would be my equation? I am trying to find VCE because I know VDE and I know VCD. Can you apply KVL here?
It would be 8 plus 4 equals VCE.
Yes, but I just want you to write it in terms of symbols like VCE, VCD, and VDE for now. So what it would be, the KVL. Okay, let's try one more thing. Let's try to say that this is VCE, right? So you can see the current is entering from negative side of VCE, right? So I just write VCE minus VCE plus, this is CD, plus minus. VCD plus, this is also plus minus, and the positive side is entering, so it's VDE is equals to 0, right? Because I feel that if you direct apply your values, you can make mistake. So you should write in terms of symbols to know, for the complicated things so that it will be easy for you. So do you think it's right, the KVL? what I did actually, another thing it's important to know, in my mind, I decided that I will take VCE right that, okay? If I am taking it as VEC, I can take it like that. But for that, you know, VCE is equals to minus VEC, right? So for that, I have to define my signs like this, right? If I define my signs like this, then it will be VEC, right? And then it will be positive VEC. But right now, as I have defined my signs like this, so it is VCE, where C is at higher voltage and E is at lower voltage. Do you think it's clear, the KVL?
Yeah.
Okay.
Yep.
So let's apply KVL here. So VCE will be VCD plus VDE, which is VCD is 8 volts and VDE is 4 volts, right? So volts. So now we know VC, we can find I6, right? Immediately I can find I6. So let's try to find this. It's Ohm's law. And I6 is VCE divided by 3 ohms. Okay, so I'm clear about that. Okay. Yes. So if you see in this circuit now, at node C, you have I6 and I7, but you don't have I5 and I2, right? At node C, you have I6 and I7, you don't have I2 and I5, right? So they are talking about node E. At node E, if you see, you have 3 currents that are coming, I4, I6, and I8, right? And okay, and as they are all coming, so you have I6 and I8, but you don't have I4, right? So I think that's the one unknown you don't have. So let's try to find I4, but as they both, three of them are coming, still in the node E, they should be equal to 0. Maybe someone is negative, someone is positive, we don't know, but all the directions are coming. So let's write KCL like that, okay? So at node E, sometimes we forget about this, but this is also an important node. So at node E, you can see apply KCL, and it will be I4 plus I6 plus I8 is equals to 0. Node E. So what is our I6? 4. I8 is 2. So I4 is minus 6 amps. Okay, so we did find I4. Okay. So by I4, I know VBE, right? So let's try to do that. Another thing here is that if you see that your current is, what you should say, negative in I4, right? So it suggests that maybe E is at higher potential than B. So maybe it's EB, but it's up to you that whatever sign you assign, you can assign, right? But the results will automatically follow that. So you don't have to worry that, oh, should I do VBE or VBEB? If you apply this fine rules, then it should be easy, like it should be correct. So what I was trying to say, let's try to find VBE. Apply Ohm's law to find VBE. So VBE is I4 into 1 ohms. VBE. Okay. So now I know VBE. So I should apply VBE, VBC, and VCE, right? So this is another loop I should consider. Okay. And in this loop, if let's say I am having this as plus minus, then this will be minus VBE. So in this loop, I will be having minus VBE plus VBC plus VCE is equals to 0. Okay. And okay, so let's see. Is equals to 0. My VCE is 12 volts. My VBC is I'm trying to find, and I know my VBE. So my VBE is minus 6 volts. So it will be so VBC I found minus 18 volts. But if you see in the book, they actually reverse the signs, right? They try to say that this is VCB, right? And which is 18 volts. So if I am following the right signs, my answer should be right. So that's why I just try to follow the signs which we normally follow, but still I am getting VBC minus 18 volts, which means my VCB is 18 volts. So it's okay. Okay, so now I can find out I5, right? So my I5, if I try to find from VBC, it will be you know, we took passive sign convention. So that's why when current is flowing like that, in this scenario, we take it as a positive thing. So if I am taking I5, this is my I5, and this VBC divided by 6 ohms. So it should be okay. So it's minus 3 amps. So I5 is good. I know it's a little bit overwhelming. Oh, we passed the time. Sorry about that. So I think I'm stopping here. I just didn't see that time. So I think I'm stopping here. We will follow it next time, okay? From the same place. Sorry about that.
Okay, thank you. Have a good weekend.
You too.
See
Thank
ya.
you.
Have a
See
good
you.
weekend.
Bye. You guys
Thank
didn't
you.
tell me that time is over.
You were on a roll and I didn't want to stop.
Oh, I'm so sorry. Okay, we will do it next time. Thank you. Thank you.
Wait, Professor, I just want to clarify one thing. For the
Mhm.
quiz, is it like everything up till today's lecture?
No. It's just first chapter.
Okay.
Okay. Thank you.
Yeah. Thank you.
Thank you.